How does temperature affect molecules? Well, today, let's find out. Well, to find the answer to that, we need to understand what a molecule is. A molecule makes up everything, literally everything, except for your body. Cells make those up. Every living thing has cells. But molecules make up this pencil, this paper, this desk. Molecules are so small that on the tip of a pin, right up here on the head, 1 million molecules can fit on the tip of this pin. Molecules are always vibrating, like they're vibrating in this pencil right now. Although you can't see it, but they are vibrating. They're so small you can't feel it or see it. When molecules get colder, they don't vibrate as much and they don't move around as much. But when molecules get warmer, they start to vibrate more. We can see this in the movement of liquids and gases. So, next up, I will be giving you a visual representation of what this looks like. So, now I will be giving you a visual representation of molecules on this website called phetcolorado.edu. They are a very good resource for pretty much anything about science, and I'm today using gas molecules 1. Hopefully in the future I'll be able to make my own, but for now we will be using PHETs. So what we will be doing is pumping in these blue molecules, or purple, whatever you want to call it, and making it really, really cold. And so this is about the molecules in our cup. Gases and liquids are pretty much the same thing, except liquids like to stay together a little more. So that is one thing that unfortunately you're not going to be able to really do with this. But it's just a good representation and show how molecules work with certain temperatures. Now we'll be pumping in the orange molecule, which will represent the food coloring. So let's go ahead and just pump in a few of those. And as you can see, it's all just kind of clumping and staying together a little bit, except for these little stragglers. But again, this is a guess. So now we are going to be testing how this would work with a lot of heat as hot water. And as you can see, with heat, it is moving around. All of the molecules are moving around a lot faster. I think I forgot to mention that. With the cold water, the molecules are moving a lot slower, barely moving, that is. So now we're going to pump in our food coloring. As you can see, it is freely spreading out so fast everywhere. And then if we cool it a little bit, just bring it down to room temperature, close to room temperature, you can see that it is... There's some still moving pretty fast, but then there are others that are very slow. So hopefully that is a pretty good visual representation, but we're going to move back into the lab. Well, now that we understand how a molecule works under different temperatures, we are going to prove our theory in that. So right here we have cold water, some room temperature water, and hot water. It looks cloudy, but that's just what hot water does. We also have this graph here, or not graph, table. We're just going to write down important things we see. So first, I'm going to do the cold water, and then the room temperature water, and then the hot water. And I'm only going to do 1 or 2 drops of food coloring. So as soon as the first drop hits, I'm going to start the timer. So as you can see during that, it didn't really spread out, it just kind of made this, I don't know what to call it, but it's just all kind of staying bunched together, if you know what I mean. So now next we're going to do the room temperature. Oh, that was 2 drops, that's fine. For 5 seconds. And it did pretty much the same thing, but now we're going to move on to the hot water. Still warm, not super hot, but it should be fine. But as you can see right here, it's kind of spreading out more at the bottom, and So as you can see over here, the water's getting like cloudier and there's more movement with the food coloring, but over here with these two, it's just kind of stationary, not really moving around. It's actually pretty interesting because it looks like with the cold it's kind of spreading out more, but with the room temperature it's kind of staying like in just one spot. But hopefully that proves our theory that, as you can see with the cold water, it's still pretty clear in these, like on the sides over here, but then with the hot water, it's filling pretty much everything. And I haven't touched these cups since we started. And it's still moving around. Now we are going to record our observations. So now the room temperature water is kind of getting more like the hot water, except as you can see, like there's still strands of it, but it's spreading out a lot more than the cold water is over here. Now, we've let these sit for a while I was writing my statements, and as you can see, water is still just kind of staying pretty much in the same spot and when we dropped it in. And then the room temperature is flowing around, but it's still kind of clumped together and a bit thicker. And then with the hot water, it's pretty much free flowing and just evenly distributed around the whole cup of water. So today we learned that yes, the temperature does affect molecules. We've learned this by what we've learned with the visual representations and our lab today. So the molecules move a lot slower in cold water. They almost are just pretty much almost vibrating like a solid, but nowhere close to that amount, obviously, because, you know, it's still a liquid. But like even if I just try to move it around a little bit, like as you can see, it's still just not really moving that much. And then as we can see right here with the hot water, the molecules are a lot warmer than these other ones, so they move faster and fill around the cup, the whole cup. So yeah, today was a pretty successful experiment. I hope that answered any questions, and I'll see you in the next one.